What we will be assembling today are these EEPROM boards, EEPROM memory boards for use on a Raspberry Pi. And the idea behind these EEPROM boards is that if you want to make your SD card read-only, or you want to have, if you have a project where you want every Raspberry Pi to have identical SD cards, but you want each Raspberry Pi to be able to have unique settings, you can store this data, if it's not a lot of data, on one of these EEPROMs. These are 1024 kilobit EEPROMs, and so we will be assembling those. They are surface mount parts, so I ordered these PC boards, and these PC boards took less than a week to arrive, from making them to ordering them to sending them out to be made, and they came back in less than a week. And then, of course, the parts order, and that came within a few days. So I've got all the parts here to assemble these things. So why don't we get started? So we've got our normal tools. We've got some needle nose. We've got side cutters. Probably won't need the wire strippers. Got some desoldering wick just in case. Got solder. Something to hold the PC boards. I'm not sure this tool is these boards are a little bit small for this tool. If this doesn't work out, we'll tape the boards down. And as for parts, of course, we have the PC boards. We've got these through-hole connectors, which is what will allow us to connect these onto the top of the Raspberry Pi. And we've got some resistors, some capacitors, and then we've got the actual memory chip. So let's get stuff set up here to get some boards assembled. Okay, there's a couple ways of going about this. One, you can use solder paste and put solder paste on the board and then place the components on the solder paste and then heat the board up in some way, either in an oven or with hot air, and that'll solder the components to the board. How I'm going to do it here is I'm going to tin the pads first and put a little bit of solder on all the pads the components are going to go on. And then I will put some solder flux on those pads. This is Amtech stuff. This is really good. This is what I use for everything. There are a lot of knockoffs of this stuff online, but if you can get a hold of this stuff, this is pretty much the best solder flux that I have come across. But we will reheat the solder with the solder flux and put the components on as the board is heated up. So we're going to go through that method. So I will go ahead and we could start by tinning the pads. So I've got the soldering iron and the hot air station set at 320 degrees Celsius, and that's usually the temperature I use. And then I actually use a 2.5% silver bearing solder just because I like the stuff. So we're going to go ahead and tin all these pads where the components will go. Hopefully not make a mess. Now these other 6 pads, these are for the through-hole connectors, so we're not going to mess with those yet. Okay, these have been tinned, so we're going to add some flux. That's more than enough. And pull our parts out. So we've got the EEPROM chip. Got one of those. And we've got a capacitor. These parts are meant to be fed into a pick and place machine, so that's why they are in a what they call a tape. So when you order these parts, they usually come in what they call cut tape. That's what this is. And then we have 2 resistors, so we'll pull the resistors out. These are really tiny. These are 0603 SMD parts, so they're not the tiniest. The tiniest that I've worked with 0402. They're quite a bit smaller. But I mean, you could still work with those. The really tiny ones are like the 0201. So I'm going to pop out 2 of those resistors. Okay, we've got 2 of those. I think I'm going to use the smaller. So I've got 2 sizes of tweezers here. I've got a more accurate size. So these are less accurate. They were cheaper. I use these for a lot of things, but when I've got really small components, I'll use these more expensive, finer tweezers. So we've got the solder paste on the board. Just going to grab our hot air tool. And we're going to slowly heat up the board. Let's place this. So this chip does have an orientation. The other parts don't. The resistors and the capacitor do not have an orientation. But this part has a pin 1 marking indicated by the dot. Hopefully it shows up. The dot's down here in the corner. And that will line up with, if we look on our circuit board, that will line up with this. So there's a line. There's 2 white lines here where this part goes, and one line is shorter than the other. Or one line, actually, this line is longer than the others. So this is pin 1 down here. So pin 1 is down here. So we want to rotate this part. And this would be the orientation we would like to place this part. So we're going to place it on there. I'm going to slowly heat this up. And as this is difficult to do on camera, as this part heats up, the solder will melt. And I'm trying to kind of position the part into place as the solder is melted. It is off. Okay, the part's positioned. So I'm going to let it cool off a little bit, and then we're going to push down on it as we warm it up to make sure that everything gets flat on the board. Also make sure that all the pins lay flat on the pads where they're supposed to be. And after it cools off, we'll let it go, and then we will put the heat on it one more time. And this is the part where you could see if the part is soldered correctly. See if I can do this on camera. So we're going to put the heat on here and heat this up. And if you notice that when the part warms up and the solder melts, the part will start to kind of dance around and will kind of find its place. The tension of the solder will kind of pull it into the position where it wants to sit. And that's how you know that the part is correctly mounted. So you kind of move the air around and it kind of moves around, so that's where it wants to sit. And that was the more difficult part to do. So now we can head off and do the capacitor, which is up in the corner. The capacitor will be quite a bit easier to do than the larger chip. It's the same idea. We'll kind of heat it up and did not heat up the way I wanted it to. Now, if you have your air set too high, you'll actually blow the parts off the board and they will disappear, never to be found again. So you do want to make sure that you don't have your air setting too high. Once the part gets soldered in and attaches to the solder, the tension of the solder will hold it onto the board, even if there is a little bit of air blowing on it. Okay, that's initially soldered. So you notice it's initially tacked down, so we're going to put some heat on it. See if I readjust the light here. We're going to put some heat on it, and the part will kind of slide into place. I think, there it goes. See, I think we need a little more flux. Give this part a little more flux. And with the flux, all right, that part's soldered in. Now I've got the two small resistors. Yeah, I got some hair on that one. Okay. Same idea, just kind of heat up the board as you place the part on. Take the heat away, and that one didn't hold. I think that one's in. We'll place the other one on, and then we will heat them both up and get them set to where they want to sit. Okay, that heated up really quick. Okay. Both of those look like they're set. Give me a little more flux. All right. Shut off the hot air, let it cool down. Now, what really works good, this flux is very easy to clean off with rubbing alcohol, either isopropyl, or I have, actually what I have, because it's easier to get here, I've got ethanol alcohol, and I usually use the higher percent stuff, so this is 99.5%. But we just get one of these Q-tips and just kind of get that flux off. That flux is really gooey and tacky, so we'll get that stuff off. And yeah, that's the pump. That's the noise in the background is the pump on the hot air workstation, the air pump. So when you shut off the hot air station, the pump is still on for a bit as it runs. It turns off the heating element, just runs cool air through it to cool it down. Okay, let's release it from here. And we'll finish cleaning up the board. I think, yeah, there's a little bit of excess solder on those resistors, so we'll go through with the soldering iron and dab that stuff off. So I'm going to go through with the hot air station pump finally turned off. I'm going to go through with the regular soldering iron and see if I can just kind of dab off the extra solder. Actually, you could use a little bit of solder wick, I think, to kind of dab that off. Yeah, you do want to be careful you don't heat the component up so you want to do it one side at a time on the component so you do not heat the entire component up, and then it will start to move on the board. And then it might get stuck to the iron and other stuff. So I think I pulled a little too much solder off that with the solder wick. So all right. I think that looks good. So the last thing we need to put in is the header connector. So clean this up, and if you take a toothbrush to this thing, you can get the flux out from between the cracks here too, which is probably something you should do when you get done. So as far as the connector goes, the trick is to get it to stay in while you're soldering. So if you can find something to prop it up against, or if you can tack on at least one of the pads, if you can get some solder on at least one of the pads, like I'm going to try to do here, then you can kind of hold it in place as you get the connector flat and lined up. You take a look at the other side to make sure the connector is lined up, because this does have a little bit of play in those holes. Okay, that looks lined up. So we'll go ahead and tack down one more pin on the opposite side. We'll push down on it again as we reheat that pin so that this sits flat. Okay, and we'll knock out the other 4 pins. All right, so that's one assembled board. So anyway, this was a short video, but just wanted to give to make a quick video of this as I was assembling these together. I've got 24 more of these to assemble. But thanks for watching. We will catch you on the next one.